We're going to get started in about 1 minute, everyone. Thanks for joining. Feel free to say hi in the chat.
Hey, everyone.
All righty. Cool. Welcome, everyone. I'm particularly excited about the LogRocket meetup today. I think it's the first full-time open source developer we've ever hosted, which I'm extremely happy about. People like Josh have been on my list for over a year now. So yeah, today this is LogRocket meetup, and we're converting a React app from JavaScript to TypeScript, specifically a Next app, which I've been building a lot more with and not using TypeScript enough. So definitely interested to see what Josh is going to take us through. So yeah, Josh Goldberg is hosting today. You can find him on Twitter. Anywhere else you typically direct people to?
Mostly Twitter and GitHub.
Cool.
Both under Joshua K. Goldberg.
Cool. Yeah, this meetup today is brought to you by LogRocket. I'm sure you've heard of our blog because that's where you found this meetup. But we also have a really awesome product for when you're building applications, fixing applications. But in a nutshell, LogRocket's a front-end application monitoring solution that combines error tracking, digital experience monitoring, performance monitoring, and then typical web analytics, just like Google Analytics. So we combine all of that. So you and engineering teams, your product teams, can be in one place looking at data to help you, fix applications more quickly, iterate on feature sets, and then integrate with all your backend monitoring tools as well. I'll just quickly show you the dashboard. So yeah, we've got a couple of different ways to look at kind of application health. And when we talk about applications, we're really talking about the people using them. So what we're actually looking at here is our issues product. And this is where we automatically surface kind of front-end exceptions, JavaScript exceptions, network errors, JavaScript errors as well, but then also these UX kind of issues that might be impacting people, using the applications you're building. So, we use a little bit of machine learning and some other fun stuff to determine something like a frustrating network request. So that's really hard to diagnose from just like a typical monitoring solution. But you can actually go see exactly what happened when someone experiences an issue like that. And you start to make those judgments like, if this frustrating network request is causing someone to not add something to a bag, like we see in this IKEA session, then, you probably should go fix that. So LogRocket really helps create better user experiences, reproduce issues more quickly and all that fun stuff. So that being said, I'm done. Josh, take it away. Yeah, this will be recorded after. And if you have any questions, leave them in the chat and I'll try to get to them. We might get them at the end. Yeah.
Super.
Thanks, Josh.
Well, thank you, Luke. And of course, LogRocket for hosting. Appreciate the intro. Very cool stuff. Hey, everyone. As was mentioned, I'm Josh, full-time open source developer working in the TypeScript areas and ecosystem. I'm really excited to talk to you today about Next.js application conversion into TypeScript because I like Next.js and TypeScript and JavaScript and React quite a lot. So to start off, I'm going to start sharing my screen. We have this nice little repo that I'm going to post in the chat, Next.js to TS under my GitHub, which you can also find if you follow me on Twitter. I just tweeted it out earlier today. Oh, thanks, Luke. So I'm going to post the link to there. You might want to follow me. I sometimes post cool things. This repo is just a standard Next.js app. It's not like a mono repo, doesn't use any fancy CSS like Tailwind or whatnot. I'm gonna just quickly show you my terminal. I previously had it on my computer and I removed it. So if you have Git installed locally, you can do this too. Git clone the URL. And I personally really like VS Code. So I'm going to open this in VS Code. You can use whatever editor you want, the online things, local, whatnot, as long as it shows source code and has some kind of TypeScript integration or plugin you can run. You don't have to use NPM. You can use Yarn if you want, but I can't guarantee that the lock file will resolve to something that works. Just going to quickly npm install, and then I'm going to npm run dev to get this running locally. I love how fast Next.js happens. So this is a very quick website that I made just for the sake of this workshop. This shows you some of my favorite movies. You can sort them by name, Z to A to Z, year, old to new, new to old. You can favorite them. So for example, I Shrek'd first. Recently, I've been really thinking hard about Everything Everywhere All at Once. It's a great movie. So I'm going to star that and show that the favorites update. So that's just this basic React app that we have set up. If you want to look into the source code, you can. Everything that's source that we're going to be touching is either in the root directory or under source. So we have some components here. This is kind of a fairly common way to set up a Next.js app. Things like favorite star, which is this nice little star emoji span. The footer says that it's powered by me and TypeScript, which you see on the bottom there. Moving on, we have some shared hooks and data. Data has the big old JSON of movies that populates this page. And then hooks like use favorites and use local storage item, which we'll get into a little bit more later. Libs is some common functionality like trying to run a JSON.parse and returning undefined if it throws an error. And pages and styles, where styles just has global CSS, very minimal. I didn't want to do anything fancy. And pages, if we get back to it, has the app index, this home page with some styles, and then the custom my app component, which imports the global styles. I see we have a question in the chat. Is Next.js to JavaScript what ASP.NET is for C#? That is a hard question to answer because they're not quite exactly the same, but you can think of it as kind of like that, yeah. Next.js is a framework that lets you write a front-end / full-stack website using React. React is a library that lets you declare how components on a page should render HTML and run logic. So yeah, if you're used to writing scaled apps in C#, you are probably using something like ASP.NET. The equivalent in JavaScript with React would be something like Next.js or Remix, yeah. So that's my answer. Boop. Oh, I hit the button at the wrong time. Sorry. But good question. And please let me know if any of the answers that I give aren't making sense or don't answer the question that you are actually hoping to get answered. All right. So hopefully by now you've all had a chance to look at the repo a little bit and get it cloned locally. I will also note that Next.js is not, I'll hit the button. Next.js is not just front end. It also lets you set up API routes. And for your pages, use functions like get server-side props and get static props, which provide data to the page. We don't have enough time to really go into a deep dive of all the things Next.js does and how they work and all this. So I'm just going to say that this get server-side props functions returns the props or data that's going to be used for the home page every time it's rendered. And in this case, we await the import of movies.json and get the movies object, which I'm going to go to definition, more on how that works later, and show you that it comes from movies.json. So if you're not yet familiar with Next.js, it's okay. We're just mostly going to go over basics of React conversion to TypeScript. If you're not familiar with JavaScript and React, then this might not be the workshop for you. Cool. So the first thing to do with converting anything from JavaScript to TypeScript is to make a tsconfig file. tsconfig.json, and I'm going to put it in the root of the directory, Next.js to ts. The tsconfig file gives you a bunch of compiler options that you can specify for TypeScript. For example, you can say whether allow.js is true or not. So whether TypeScript is allowed to look at JavaScript files. Now, this is an important option because the way that we're going to run this conversion today is the way that a lot of companies and a lot of projects end up converting. We're going to do it one file at a time. We're going to go through our components. We're going to find ones that are easiest to start with, that have no dependencies in other ones, and we're going to rename them from JS to something like .ts or .tsx. But before we do all that, I want to note that you don't have to set up your own tsconfig file and know how that works. You can npm I TypeScript save dev to add TypeScript as a dev dependency, and then run npx TypeScript -- init. Oops, or is it tsc -- init? There we go. npx tsc -- init after npm I TypeScript save dev. So what these two commands do are, first, I added TypeScript as a dev dependency because the TypeScript package in npm is what lets you run TypeScript. And then I added a tsconfig file, and it sets up a few basic defaults that we can keep for a little while. Cool. So before we go any further, and again, please do ask questions if anything's not clear, I want to quickly cover what TypeScript actually is, because I just told you to run some command from TypeScript. I didn't actually say what it is or why we need TypeScript. TypeScript is a few things. To start, it's a specification of a language. Instead of writing JavaScript, functions say hello, say return hi, we are now writing in a language that contains all the things in JavaScript, but also adds in the ability for us to declare types of things. Let's say that we have let name equals hi, or let's say name is set hi later. This is all valid JavaScript. In TypeScript, we can do these things called type annotations. Let's say name is string. We change language mode to TypeScript. These type annotations are in the source code, and they allow us to describe what our code is supposed to do. I am describing here that this variable is supposed to store something of type string. So later on, if I say name equals 1337, TypeScript will yell at us saying, hey, you were supposed to put a string there. Type number is not assignable to type string. Which brings us to the second thing that TypeScript is. It's also a program, a JavaScript module that looks at your code and yells at you if your syntax indicates something that doesn't work in reality. Like if you're trying to assign a number to a variable that's type string. Now, there are great editor integrations for TypeScript in a lot of programming editors, such as VS Code. You can see here that I get this little red squiggly, and when I hover my mouse, it shows me the definition of the variable and any complaint from the squiggly. You can also go to typescriptlang.org/play and put TypeScript code on the left and look at different outputs on the right. To start, this is the equivalent JavaScript. We can see, and I'll zoom in a few times. It looks pretty similar. So there's just no :string. TypeScript code, the syntax, compiles down to JavaScript, which lets you then run it anywhere that you would run JavaScript normally, like Node, the browser, wherever. Also, the playground will let you know if there are any errors and gives you the same nice little squiggly with the complaint. Fun fact, the same text editor powers the TypeScript playground as VS Code. It's called Monaco. It's open source and comes out of the VS Code source. Fun little snippet there. Cool. So we've covered that TypeScript is a language specification like JavaScript, and it's also a program that looks at your JavaScript, complains about it if necessary, looks at your TypeScript and complains about it if necessary, and then also creates output JavaScript. There are a few other things it does, but we don't need to cover those yet. So let's look at our tsconfig that TypeScript made for us. It notes at the top, visit aka.ms/tsconfig to read more about this. This is not something we need to do now. I'm actually going to delete all these commented out things using my fancy VS Code multi-select and formats. Also going to delete any comments because we're just going to go over them now. Oop. Cool. So here we have, I'm going to sort these alphabetically because that's how I personally like to read config files. We have a few settings here, and I'm going to actually enable allow.js so that we can include JavaScript files if we want. A few things to note. I'm just going to go through these in order. ES module interop makes TypeScript assume that you're using modern JavaScript bundlers that allow you to work with ECMAScript modules in a more friendly way. We don't need to go into that now. Course consistent casing and file names is important if you're running on Windows, because Windows is less strict about whether two files can have the same name with different cases. We're going to assume actually that the module is ES Next, because that's what our code uses. I'm using import export syntax. Skip libcheck is a small performance enhancement so that TypeScript doesn't check whether all your node modules or libraries are valid TypeScript types. Strict is probably the most important one here. It says enable all the strict TypeScript settings. TypeScript can actually be configured to be very permissive, very hands-off. It might work, so it's okay with your code, but it's highly recommended in especially enterprise and larger code bases that are important to use strict mode, which enables more strict tooling. And the target is what ECMAScript environment we're running in. If it's IE 11, then it might be as low as ES 2015. Here we're running in the year 2022, so I'm going to say ES 2020, which is supported by most browsers works. Cool. If you remember none of that, that's okay. Just tsc --init gives you this stuff and links to documentation. And if you want to also be able to run with JavaScript files, add allow.js. So I'm going to use npx tsc --watch, which starts the TypeScript type checker. That's the program that comes with TypeScript that looks at my files and complains if there's any issue with them. I'm also noting that I forgot, to add no omits. We don't need to convert our files from TS to JS. We are using a bundler, Webpack and Next.js, so it does it for us. So I'm going to add no omit, which is a compiler option that tells TypeScript not to create output JS files alongside TS files. Cool. So now we're running TypeScript in watch mode and is complaining about 0 things because we haven't written any TypeScript code yet. Now, if I start a new terminal and do npm run dev to run Next.js, next we'll take a look at our codes, see that there's a TS config, and mess with it a little bit for us. Now, we don't really need to go over this too much, but the important thing is that now if I visit the Next.js server, here we go, it still works. And Next.js has set settings that allow it to work with TypeScript automatically for us, which is actually a really nice feature that Next.js does. Could I elaborate on why we don't need TypeScript to shove the JS files into a dist or dest folder? If we were running, say, a node CLI project, a project that creates a JavaScript package meant to be consumed as a node module, then yeah, we would need that. But we are running a Next.js app, next.config.js, which does not have any outputs. It reads source code in directly from your source directory, from your components and pages directories, and then turns that into a website immediately for you. So if we wanted to, say, create an output, we would be able to use TypeScript to do that. We would not use a no omit. But in this case, we're not emitting any new files. We weren't before, and we're still not now. Next.js is able to use Webpack to read in TypeScript source code directly. It doesn't need to make a new file from it. Good question. Please let me know if that doesn't make sense. And I appreciate everyone who asks questions. They make me feel like we're actually making progress. Cool. So I'm gonna get into the meat of this workshop now, if you'll pardon the phrasing. I'm going to now get into the core part where we're set up. We've configured TypeScript a little bit. We are now ready to start converting from plain old vanilla, as they say, JavaScript to TypeScript. Yay, excitement. The way that we typically would do this in an application is with a depth-first search to try to find the leaf nodes in the dependency tree. What does that mean? Different components import each other, and it's easiest to start with components that don't import any other components. For example, if I were to try to convert my pages/index from JavaScript to TypeScript, TypeScript might get confused because I haven't yet converted any of these dependencies from JS to TS. So if we were to make a tree or a description of all the arrows pointing, this file needs that file needs that file, then we would go to the files that are at the leaf ends or the very ends of that tree that don't have any imports. So I'm going to right click, go to definition on these imports, which brings me to the files that they import. I see index, imports layout, imports footer, and that's it. Okay. So I've done a depth first search. I've gone as deep as possible. And now I'm going to rename footer from JS to TSX. Voila, we have converted our first file from JS to TS. Very exciting. Now, just to make sure that this still works, yay, I'm going to save and then look at my web page. Still works, yay. Whoops, that's a link. So we know that Next.js is able to live reload as we rename our files from JS to TS, which is pretty cool. I will also note that you may have seen .ts and or .tsx as a file extension before. You need to use TSX when you're working with JSX syntax, because there are some TypeScript language features, one specifically that is kind of ambiguous that looks similar to JSX. So if you want to use that language feature, which we won't get into, you go into .ts file. And if you want to use JSX, you make it a TSX file. The kind of industry standard is to use TSX only if you need, only in files that actually contain JSX syntax. And what's also fun here is that we have no compiler errors. I'm going to switch to my terminal. File change detected, found 0 errors. If I hit save, we see the timestamp updates. Great. This is actually pretty common in TypeScript files. As you convert them, a lot of files just work. There's no new syntax we need. And that's one of the beauties of TypeScript. If it's valid JavaScript, there's a good chance it's just going to work. Yay. So let's go back up. This file doesn't import any source code. So there's no more JavaScript we need to modify. We're back up to layout, which just imports from a CSS file. And I'll go into how that works in a little bit. But I'm going to go to, actually, let me just go to definition on footer and remove my still works yay. But yeah, I'm going to go to layout and rename it to TSX. Now we get our first TypeScript error of the workshop in our source code. Very exciting. We have squigglies. Children. Binding element children implicitly has an any type. What does that mean? Description implicitly has any. What is that? Title has any. In TypeScript, the any type, / any, refers to something that can be anything, any other value. Something that could be a string or an array of numbers or an object or null or whatever. It is the hands-off TypeScript, I know what I'm doing, don't try to type check me type, which is oftentimes not good. If TypeScript doesn't have the ability to know what type something is, it can't give you type checking or development time help on that. In this case, when we look at the layout component, we have no way of knowing just from layout what types these three are supposed to be. Is children a string? Is it a React node or JSX element? What is description? What is title? We don't know. Now, in theory, you could look at all the places that layout is used. You could right-click, find all references, see it's used in an index, and see, okay, description is a string because it's this variable, but that would be really expensive. TypeScript would have to look at all the places layout is used, look at all those props, figure out what types those props are supposed to be, which in this case would mean looking at this description variable and seeing it's this string. So TypeScript doesn't do that. That would slow it down something horrible. And also it would kind of defeat the purpose of type checking. It's made that you should be able to say what stuff is supposed to be so that later uses can be type checked to see if they match up. So I'm going to add my first piece of TypeScript syntax. I'm going to describe an interface, which is a description of what an object is supposed to look like. Layout props, which has children, which can be type react.react node, description, string, title, string. Now, react.react node is kind of a fancy way of saying anything that's allowed to be the children in a React component. It's a React element, which is some kind of element. I'm not going to go too deep into that because I actually don't know what that is myself. Go back. By the way, you can command or in Mac key, Apple key, and click to go to definition. So this ends up being string or number or Boolean or null or undefined or JSX element. So that's really any child. These two are strings. And I'm going to use a type definition to say that this destructured syntax, this props object, let me expand a bit. These things are supposed to be type layout props. So in doing so, in creating this interface and adding a type annotation here, I have said that children is type React node. It's allowed to be whatever JSX element or similar you can pass to React component. Description and title are supposed to be strings. And we can see here that now that I add in this layout props type annotation, we have no complaints. If I were to have forgotten that, if I just made the interface but never used it, we see the same complaints in our terminal that we see in VS Code. Cool. And also just to be sure that things are actually working, I'm going to add Yippee as code to the component, and then the page reloads with Yippee. Yay. So we've now converted this component to TypeScript. We've added an interface to describe the props and used the props interface to tell TypeScript that explicitly this props object with these three things is supposed to be that type. By the way, if you're not familiar with this destructuring syntax, it's the same as having a single parameter and then grabbing the members of that parameter, which is itself the exact same as doing const children equals props.children, description equals props.description, title equals props.title. These are all the same thing. This is just fancy code way for me to use less coding, less typing to fill it out. Ooh, great question in the chat that I was planning on answering later. I'm a beginner in using TypeScript. Is there any journal or documentation that can help me to understand these? Yes. The first resource I recommend to people, because it's free, open source, and made by the TypeScript team, is TypeScriptlang.org. By the way, I forgot to post the link to the playground earlier. Apologies. The TypeScript Lang website is fantastic. It's got a lot of documentation. Let me maximize. It gives you links to the playground that I'm using, docs, which has TypeScript for different types of people, like say people who know JavaScript but not TypeScript. So highly recommend the TypeScript docs. I also am a published author as of this summer, and I wrote a book on specifically learning TypeScript with O'Reilly. Yay. So learningtypescript.com, I think it is the best book for learning TypeScript if all you know is JavaScript. Also, it's the best if you also know other things, but it doesn't assume any C# or C++ or types, whatever language understanding. So this is a book you can get it on Amazon, on the O'Reilly platform. Highly recommend. And then, yes, as Luke is posting, the LogRocket blog has a lot of really great TypeScript posts. So highly recommend checking that out. Cool. So to summarize, the TypeScriptlang.org website is great, and it has guides for different types of developers. It has a handbook with a lot of really good documentation pages explaining how TypeScript works, as well as the link to the playground. And then learningtypescript.com is my book, which I think is a fantastic way to learn. It's through O'Reilly. And then the TypeScript posts on the LogRocket blog. Great question. Cool, back to the coding. So we've converted layout to TypeScript. So I'm going to go back up, and we see that the source pages index component also has imports from a few other places, a couple of components. So I'm going to go to definition on movies list. Movies list imports these hooks, which imports another hook, which imports that try parse lib. Okay, cool. I see there's a question in the chat. When is it necessary to use TypeScript over JavaScript? I see that it's already been 30 minutes, and I'd like to have some significant progress in the conversion within the next 10, 15 minutes, because I know folks are going to want to leave after 45 to 60 at most. So I'm going to wait to answer that till the end, but I promise I will. So because this try parse library doesn't need any JSX syntax inside, we can convert it to just TS, and we get the nice first complaints data. You might have noticed when I'm converting things from JavaScript to TypeScript so far, I haven't been looking at what uses them. Oftentimes you don't really need to. You can just look at the function, and if you understand it well enough on your own, you don't need to understand what its uses is really supposed to be. Here, I can't really make too many mistakes trying to guess what this is, because I see there's only really one line of code that uses this data parameter, and data is being passed to JSON.parse, which actually, fun fact, if we hover a mouse over it, TypeScript knows this is a built-in method on this built-in JSON object, and it's able to give us a description of what's in data, or what's in, pardon me, JSON.parse. It is a function where the text parameter is type string, and then there are a couple other things you can use with this reviver, which we don't need to go into, we don't use it. So because JSON.parse is known to take in text string, TypeScript can actually quick fix for us. Let's see if it works. Try to infer parameter types from usage, and yep, TypeScript filled in for us, the data is type string. Awesome. Now, if we wanted to do that on our own, we could have done typing on our own. And I want to talk a little bit about how TypeScript knows these things. If we right-click on parse and then go to definition, we get taken to this lib.es5 DTS file. DTS files, or declaration or definition files, are how TypeScript code can be told what JavaScript stuff looks like. All of your NPM modules, even if they're originally written in TypeScript, still publish JavaScript stuff. And there is also a lot of stuff built into JavaScript, like JSON.parse, and then platform-specific things like node modules and browser APIs that need to be described so your code knows how they work. Your TypeScript needs to know that JSON.parse takes in text string and returns anything, who knows. So these DTS files, they look like the TypeScript syntax, but all they do is declare stuff. They declare that there is some global variable JSON, which is this JSON type, which we see is this interface JSON here. We see that URI error is this URI error constructor, which is some whole other thing we won't get into. So DTS files, you can think as TypeScript minus JavaScript. It's just the type system descriptions. And because they exist, in some cases are built in, for example, built-in things like JSON.parse, their DTS is always used in your compiles. We know that data is type string. Cool. Now, try parse is typed as returning any. That is not the most safe thing. I mentioned earlier that any isn't super safe, that it tells TypeScript, hey, this can be anything, don't type check it, let me do whatever I want. And I want to show you an example of that. Let's say we use const my stuff equals try parse, something that's clearly invalid JSON. This is not valid code, or not valid JSON code in here. And if we do my stuff.hello, it's allowed. My stuff dot call it as a function equals 3 dot to uppercase. All this stuff is allowed. So there's a type in TypeScript called unknown, which would let TypeScript catch errors here. And unknown is a little safer than any. It is kind of like any, but it tells TypeScript, I don't know what this is, and also don't let me do whatever I want. If I try to access a member of something type unknown, TypeScript says, hey, object is of type unknown, you're not allowed to access members of it. Because who knows, maybe it'll be undefined, and at runtime, you'd get a type error saying cannot read properties of undefined. So the only way for us to check if my stuff is able to access .hello is at runtime. If we do something like if type of my stuff equals string, then inside here, TypeScript knows that the only way that this if statement or if block can be executed, the body, is if my stuff is a string. So this is a concept of type narrowing. TypeScript sees that some variable, some value is a potentially wide type, meaning it could be anything or a few different things. But inside a certain area of your code, the type has to be something more narrow, more specific. Otherwise, that block of code wouldn't run. So here we do my stuff.toUppercase. That's allowed inside the if statement. because this if statement is only run if my stuff is a string. Whereas outside the if statement, my stuff is unknown, so we get an error there. And that's why I'm adding this explicit type annotation unknown to the function. JSON.parse for legacy reasons returns any, and we really want to return unknown. It's more safe. Cool. And moving back to use local storage item, we can now convert this file to TS. So this file is our first kind of complex file that we're going to convert. Now, I realize that we promised about a 40-minute ETA to completion or to finishing up the core part of the workshop earlier. This is the last file that I would consider to be introducing a lot of new information. I'm going to go through and convert the entire thing to TypeScript just so you all have a full reference. There are a few other things I'm going to cover, like tests, and if we have time, linting at the end. But this is really the last thing that I would say. If you want to come to this workshop, really stick around and see this. And because we're nearing the end of the you must stay for it part of it, I'm going to answer the question, when is it necessary to use TypeScript over JavaScript? I would say it depends on your definition of necessary. You don't have to use TypeScript. You never have to use TypeScript, or very rarely. Anything you can do in JavaScript, you can pretty much do in TypeScript and vice versa. So if you really wanted to, you could take your 1 million line of code enterprise apps and write them entirely in JavaScript without TypeScript. That's what we did 10 years ago. But I would say TypeScript starts to be useful when you have multiple files and or multiple developers. TypeScript gives you type safety, so it makes it much more safe to write code. And it gives you better documentation for code, which we'll see as we convert this function to TypeScript. So my personal rule of thumb is if my personal project has more than 3 files, or if I'm going to work on it with another person, I will use TypeScript, which means the vast majority of time I'm using TypeScript. The only time when I don't use it is when I'm just like doing some quick little hacky thing where I just want to get it to work quickly. I don't need the type safety so much. Different people have different opinions. And some people will say, oh, you should only use it if it's a giant app. And I disagree with that. I think depending on how familiar you are with TypeScript, it's really useful. So I would recommend using it on anything more than 3 files, just to give yourself more experience with it. If you don't, if you don't have an extremely pressing deadline, and doing so would make you take much longer than the deadline. So in summary, I'd say more than 3 files, any number of developers more than 1, I recommend using TypeScript at the very least to teach yourself it, but you don't have to if you can't, if you have a deadline. Cool. So I mentioned earlier that sometimes you don't really need to look and see uses for where a function is used to understand its parameters types. And that's honestly most of the work in converting a React app from JS to TS. Most of the work I have seen in my experience is converting components to user props interface or helping hook functions get parameter types. Now here we see that someone has written very helpful JS doc descriptions. They've said that the key parameter, which is the key to store in local storage, for this use local storage item hook, which we still haven't looked at to understand what it does, is type string. So I'm just going to assume they're right. And if later on we discover they're wrong, TypeScript will yell at us, key : string. And I'm going to remove that from the JS doc because kind of unnecessary now to have the types in JS doc now that we use in TypeScript. Oops. This asterisk thing, I'm guessing the JS doc user meant to be, not sure, any, so I'm just going to remove it. This is actually one of the problems with JS doc, that there's no real standard for it. Like there kind of is a community standard, but it's not enforced in your code. Like if we had written any or anything, lol, that would have been equally valid in the compiler's eyes. So it's nice to use TypeScript to standardize things. There's also kind of a common practice of using array brackets to indicate that a parameter is optional in JS doc. So I'm going to remove those because TypeScript knows that this parameter defaults to blank value. And I see that it's saying it returns asterisk comma function. So, okay, this thing TypeScript has inferred to return any, so we're going to have to fix that up. Or any array, so an array of anything. So here we get into the concept of generics. Now, you might have heard of generics before. You might have heard people mutter in fear with them or curse them or complain about them. Generics are a really powerful language feature in typed languages such as TypeScript, and I would caution you not to overuse them. They are very useful where useful and very annoying if you overuse them. So keep that in mind, that they are useful only in specific cases when they should be used. This use local storage item hook, we're going to have to understand. It takes in a key to store in local storage and a blank value to use before mounting, and then a value to fill in if not already stored. It then uses React state on that blank value, and then sets an effect to try to parse local storage.getItem and set it as the item's value, or the initial value, which is by default the blank value, and then it returns a tuple or array of size fixed size containing the item and a function that lets you update the item. Okay, so this use local storage item is a hook that's supposed to store some value in local storage under a key. If we go right-click find all references and look at the first place it's used, we see that use local storage item stores under movie favorite this blank value and then an initial value. And that ID, I just happen to know off the top of my head, is the ID for the Shrek movie. That's the default favorites, which we saw earlier. So this use local storage item is a kind of common hook a lot of smaller client apps that store in local storage use. So we know that the value is some kind of asterisk thing. I'm going to call it a generic value, where this value type might be different each time the use local storage item hook is called. We might be storing under my number a number, and we might be storing under my number or my string some kind of string value. And what is this complaining about? I'm getting a lint rule that I shouldn't be calling use local storage item in a outside of a component, but that's okay. So here, if you call it with my number and 0, TypeScript will be able to infer that the generic, the type parameter value is a number, because blank value is a number, which then means that initial value is a number, optional parameter number, which we indicate with this question mark in TypeScript. So that's the generic. That's, hey, if you call it with a particular type, then that's what that value generic resolves to. Here it's number. And in use local storage item, if we call it with blank value string, then the value generic resolves to string. Each time you call this function in code, it might be a different generic. So here we see that blank value is type value and initial value is an optional parameter that's type value. So that's generics. Now, just looking through this explanation, it might not seem like they're too complicated, but I've seen functions that have like 3 generics, and they also don't even use these nice names. They use like T and U and what do you V, W, whatever. And then they do all these fancy things with them. Code can get complex, so I'd recommend if you have a function, try to keep it to 1 or 2 generics at most. I don't have any too complex ones in this repo, but trust me, they're out there and they make things hard to read. So just like with any other code, give it a nice informative name, unless it's like something really basic, like T is commonly used if you have an array generic, similar to how for I equals 0 is common. So that's generics. Next up, I'm gonna look at this red squiggly here. We're seeing that set item is trying to take in try parse of local storage.getItem and is complaining that argument of type unknown is not assignable to parameter of type set state action value, which just off the top of my head, I know that set item is supposed to take in either something of type value, blank value is allowed, or a function that returns something of type value. That's just how set state works in React hooks. I'm going to comment those out. And here we're seeing that it's complaining that local storage get item key I'm actually gonna split this out. Const new value equals this because it's hard to tell where the squiggly is coming from. New value. And we see we actually have two squigglies here. And this is actually a really great tip for debugging TypeScript complaints. If you ever see two of them in a hover, extract something out to a new variable so that you can see where the squigglies are more specifically. And fun fact, TypeScript actually has a little thing for this. If you select some area of code, right click and go to refactor, or just press the lightning bolt there, you'll see a bunch of little refactors. I'm sorry, I can't zoom in on them. And the first one here, extracts to constant in enclosing scope, means cut and paste this into a new variable and offer what the name is, which I'm going to call new value. Cool. Thanks, TypeScript. So local storage get item key is returning string or null, and TypeScript is yelling at us that try parse is taking in string, not string or null. Ha! Glad to see I've blown someone's mind here. The reaction I'm looking for. Thanks, Luke. So data is supposed to be string, but here we're seeing that local storage get item key is actually allowed to be null. But here we're seeing that if we pass in null to json.parse, that's not allowed because TypeScript thinks json.parse is supposed to return or take in a string. Now, this is the first type mismatch we are seeing in the code. I'm going to have to zoom out to show both at the same time. Let me know if that's too zoomed out. Sometimes when you're converting stuff from JS to TS, you will find places where TypeScript is yelling at you for code that seems perfectly valid. And that's okay. TypeScript is normally right, but sometimes it's not. In this case, we happen to know that json.parse of data, where data is null, will actually don't know what that does. Let's open a node console and json.parse null. We'll see that it returns null. So that's actually kind of a valid thing. And I think the reason why is that it coerces it to a string. So fine. So in this case, what we're going to do is we're going to tell TypeScript to shut up about it. We're going to use this bang here, this exclamation points. This operator, this non-null assertion operator is called non-null assertion, tells TypeScript, hey, I know you think this might be null and or undefined, but I don't care. I know this is allowed to work as is. So data is actually allowed to be null in this case. So just pretend it's string. And actually, if we run the same refactor, I'm going to use the shortcut on my keyboard, Apple period, to open that menu and enter. Const data, I am sure this is okay. We see that data, I'm sure this is okay, is string, even though data originally was string or null. So we've gotten rid of one squiggly. Yay. The next complaint is that this set item new value is taking in type argument type unknown, but it's supposed to be a set state parameter argument type value. Now, this is another case where TypeScript's kind of right, but we know that this is safe. TypeScript is complaining that it doesn't know what new value is supposed to be. We could be passing it something totally weird, an empty object, something invalid, whatever. In this case, we want to kind of assume that this is going to work as allowed. So I'm going to say as value or undefined, which is another type of type assertion. This is telling TypeScript, I know you think this is supposed to be type unknown, but I'm telling you that this is actually type value or undefined. TypeScript is complaining that that seems really suspicious to me. Conversion of type string or null to type value or undefined. Oh, whoops, I put it in the wrong place. Oh, I'm sorry. This is, here we go. I put it in the wrong place. There we go. This is value or undefined is not assignable because undefined is not assignable. And that's right. We're set item isn't supposed to take in undefined. It's supposed to take in value. So I've actually put this in total wrong place. I'm going to wrap this in parentheses and put as value undefined there. Sorry, it's been a little bit, parentheses are hard. So we're saying the returned result from try parse, even though TypeScript isn't willing to assume it's anything, we know that it's going to be value or undefined. And if it doesn't exist, we use initial value. So here, if we hover over new value, TypeScript has concluded that it's always going to be value. So now we have successfully gotten rid of all the red squigglies from this file. I will answer in the chat. What does data exclamation mark mean? I thought it should be not data. Yeah, it's a little ambiguous that it's the same exclamation mark you would use to logically negate something. In this case, data exclamation mark is the type, the non-null assertion operator that I was mentioning. I'm actually going to pop this into the TypeScript playground so you can see the result of it. Data exclamation mark here says to TypeScript in the type system, hey, I know you think this is maybe null or undefined, but it's actually whatever the type is that's not nullable. And it's a pure type system operator. It goes away if you compile to JavaScript. It's just in the type system. So it's a completely different operator than the logical negation, which is an actual runtime operator, which is in JavaScript. This is equivalent to saying data as string. It's just a nice little shortcut to say it is whatever its type is, but remove null or undefined. Ooh, another good question. Should the value or undefined also go where the unknown is in the try parse function? So this is a TypeScript best practices question. In theory, we could have made try parse generic. We could say this is value, and then we return value or undefined. That is a possibility. I'm actually going to put it in as a comment. The problem, though, is that this is an unsafe thing. We could have, say, try parse value here. We could have told TypeScript, hey, I don't care what you think JSON.parse actually returns. I'm telling you that it's returning value. And we don't even need to use a cast for that because JSON.parse returns any, which is telling TypeScript, this is anything, don't type check it. But this violates a relatively important rule in TypeScript generics called the golden rule. The golden rule of generics says, if a generic is only used once, then it's probably, once or twice, it's probably not worth it. In this case, it's telling us that try parse, the generic is only used to describe the return type. This type parameter value is only being used to describe the return type. And it's not actually validating what the data is or what the contents are. So we can say try parse number, try parse string, let's say, and TypeScript will think that, okay, they've told me the value is string, so the return type is string or undefined. And then we could pass it total garbage. And this is unsafe. Fun fact about TypeScript, it is not a completely sound type system. There are easy ways, very easy ways to get around type safety and to tell TypeScript something that's actually wrong, and then it'll say, okay, and not give you any complaints. We're seeing this right now here with giving try parse a type parameter, or excuse me, a type argument of string. The golden rule of generics is really well described in the effective TypeScript blog post, which I'm going to link in the chat, maybe through Luke. Effective TypeScript is a fantastic book. I highly recommend it, especially after learning TypeScript, because, thank you, Luke, it is 62 specific ways to improve your TypeScript. It's got a lot of really good advice. Dan Vanderkam is a very smart person. And it covers actually a very similar case to this, parse YAML instead of JSON. So my recommendation is follow the golden rule. Don't use a generic type argument unless it actually is being used in multiple cases, like say both for parameter type and your return type, because otherwise it's not quite safe. You're just telling TypeScript something that might not be true. Good question. Oops, I meant to comment that out. There you go. All right. Do we need to define generics, or does this defeat the purpose of generics? I'm sorry, I'm not sure what you mean by that. I think I might have just answered that with the golden rule of generics, saying that this isn't super type safe, but if you could elaborate, I would appreciate that. I'll try to answer. Cool. So here we're saying as value or undefined, which is a type assertion. And I have again put it in the wrong place. There we go. Okay. Cool. Your value is type any. So we're not actually quite done. We have a couple more things left to do with converting this function in TypeScript. Sorry, these have been very good questions. So I'm taking a little longer than normal. For starters, oh, awesome, I'm glad. Yay. For starters, we see here that parameter value is type any. If we were going further, we would have eventually seen that update item has this any type for its value. But since I want to be able to make this complete now, I'll just give you a hint. Use callback is a generic function. It takes in a type parameter for what the callback function is supposed to be. In this case, right now, TypeScript doesn't know what this value type is supposed to be. So it's assuming it's any, and it sees that the function returns void. But that's not great because any is not very type safe. So we're going to want to see where is update item used so we can fill in the type value. And if we hover over use local storage item, you might have seen this earlier. It's got this weird array return type. It's saying, I'm going to copy and paste this here. It's saying, I'll make it an explicit return type, which fun fact you can do, though oftentimes it's unnecessary because TypeScript already inferred it. It's saying the return type is value, or this is a function syntax, a function that takes in a parameter named value of type any and returns void, meaning it returns nothing. And it's an array of these things. But this isn't super exactly what we want. We want to say that it returns a tuple, meaning an array of a fixed size with known things at its locations. We know the first item is value, and the second item is that function that takes in any and returns void. So I'm actually going to give this function an explicit return type, because TypeScript, when it sees an array, just assumes that it's an array where each item could be any of the possible items in the array. Where let's say that we have const values equals 1, 2, 3. TypeScript isn't going to assume that values is type tuple 1, 2, 3. It will assume that it's type number, that anything in values could be a number, because otherwise it would be very annoying to deal with. You'd have to only assume that this is an array of size 3 with those values. Another way of doing this, by the way, is with one last new piece of TypeScript syntax I want to cover for now, and as const. We saw earlier that there was this syntax shortcut that we use in try-parse for a type assertion. The bang says it's whatever the type was, but without null or undefined. Here we're seeing this new as const, which is whatever this type was going to be, but the most constant read-only version of it. So don't assume that each item could be any of the other items types. Just assume that this is a fixed size array or tuple. And in this case, it ends up assuming, if we hover over use local storage item, that it is a read-only array where the first item is value, and the second item is value any returning void. So now we are ready, and I see there's a question in the chat. I'll answer it soon. It's a good question. We are ready to start looking at where a use local storage item is meant to be used. We see that it's set favorites is in this usage where we call use local storage item. And we could go through, but just for the sake of time, I'm actually just going to take a little shortcut and just look at the source code of this function. And I'll let you know that normally what I would do is I'd right click, find all references, and try to figure out through all the places that use this function, well, what are they using this set whatever for? But here we can see that this value parameter is being passed directly to set item, which takes in value. the type parameter value. So I'm just going to call it value. So we're cheating a little bit, but we can make this conclusion because, well, the value is immediately used in a couple of places. One more squiggly, which I promise is the last where this file comes up. Local storage.setItem key value argument of type uppercase V value is not assignable to parameter type string. Fun fact, local storage set item, go to definition. If we go to the DTS for the DOM library, JSON set item takes in type string, but here we're passing in value, which is the object. So it seems to me like TypeScript has just blatantly found a mismatch, a potential bug. Now you're supposed to pass in string, but we're passing in an object. And in fact, particularly interactive folks may have noticed that if you were to refresh the page, local storage is not actually successfully storing our favorites. And if we go to the DevTools console and look at local storage, we see movie's favorite is object. This is a bug. This is a bad. TypeScript has found a bug in our code. So that's pretty cool. The first bug TypeScript's found for us. And in fact, the developer knew there might be a bug because that smart developer they put a little thinking face emoji there. So yay, TypeScript found a bug for us. In real conversions, in my entire career, I have yet to find a real conversion from JS to TS that did not find at least one significant bug, like a real bug like this. So that's another example of when should you use TypeScript over JavaScript if you want to catch your bugs more quickly. It won't catch all your bugs. It certainly doesn't replace testing, but it's quite useful. So what do we do? What do we do when we find a bug? We have a few options. I happen to know off the top of my head that JSON.stringify is what you're supposed to use in these cases. So if we go back to the page, hit a couple favorites, local storage, get item, movie. Oh, geez, I already forget what it was. Local storage, get item. We see, oh yeah, movie's favorite now is the stringified object. So if we refresh, they stay. However, the right practice in my experience is not to change any runtime behavior in your TypeScript conversion. I would strongly recommend not to change your output JavaScript when you're converting to TypeScript. The reason for this is that when you are converting a lot of stuff from JS to TS, you're going to be making potentially a lot of lines of code changed in your pull request, in your diff. And it is really annoying to have to review multiple types of things in a pull request that's large. People are going to be reviewing both the converting of JS to TS and then maybe also any runtime logic changes from your conversion. So unless you are 100% sure and want to take a little bit of a risk, I would recommend, instead of fixing the bug, use TS expect error. This is a small comment you can put in code. This is probably a bug we should investigate. It tells TypeScript to shut up about it. Whatever's on the next line, if there's an error, ignore it. And in this case, I also recommend putting a little description, takes in string, not the value object. I'd highly recommend putting a little explanation with your TS expect errors. The nice thing about TS expect error is that if someone were to fix things, let's say by properly using JSON stringify, TypeScript will yell at you saying, hey, you expected an error there. It is not an error, so this unused directive is probably a waste of time. This is different from TS ignore, which is a slightly older directive, which said, if there is an error on the next line, ignore it. TS expect error says, there is an error on the next line, ignore it. And if there isn't an error, yell at me. So yay, we found a bug and we have restrained ourselves, used personal calmness to not fix the bug. Great. I'm going to finally answer the question in the chat soon, I promise. But I want to reiterate that this is the most important stuff in this workshop that we've covered. So if you're getting tired and this is a lot of information, which I personally would be at this moment because I can't stand more than 45 information minutes in a row, then there will be a recording of the talk. But I'm going to keep going and go into some more edge cases and other cool features of TypeScript. So if you need to leave now, no worries. Thanks for attending. Can you please show an example with a TS component, which is possibly extending FC or function component? Transform dialog, reacted FC, some interface with use states. What is all that? So I'm going to make a new file. So here's the syntax that the person in the chat, very good question, mentioned. I'm going to export it. There is another way. I'm going to just put this up for now and then talk. There is another way to describe a component. We looked at, let's say, the footer component, and we didn't add any fancy TypeScript things there. Some folks like to explicitly say that something is a React.fc, which is shorthand for function component. So we could have said export const footer, type annotation on it on the variable saying React.fc equals, and our function returning some JSX. Pardon my throat. React.fc is a type or an interface. In TypeScript, there is this type syntax, which is sometimes used similarly to interfaces. It says, whenever I say this thing, what I really mean is that other thing. So in this case, whenever we say .react.fc with an optional type parameter, which defaults to the empty object, so nothing, what we actually mean is React's function component, which is an interface that describes a function that takes in props and optionally some context thing. I've never used that. And then it can also have prop types, context types, default props, and display name mentioned. Cool. The props argument to the component is form dialog props. That's the generic type parameter. So let's say this takes in text or initial text string. Here we go. So the nice thing about React.fc is that you can declare your type there. Let's say that we use this interface for our props type, and then TypeScript will know what the type is as you start typing out your props. So as I type INI, the TypeScript language server, the part of it integrating with VS Code, knows that I only have this one prop type initial text, so I can click that to fill in. Cool. And then one more thing, because this is probably something you've used a lot. Maybe you have like a function on change, new text string. This is an example of a prop that is a function type, which takes in a single parameter and then returns nothing. So maybe you actually have form with input type equals text, initial or value equals initial text, then on change equals event on change. I need that parameter. Getting overlapping the side of my screen. On change events dot targets dot value. Here we go. So that's an example. Oh boy, I messed up my curly brackets somewhere. Oh, there we go. No. There we go. All right. So that's an example of what you might use for a component that takes in a prop that is a function. Let me know if that's not the type of example you were looking for. And we also will get to something that looks more like that later in the workshop. Cool. I'm going to save this and then I'll post a PR later. Yay, glad it was. That has this stuff. So example FC. Cool. All right, moving on. Use local storage item. Where was I? Final references. I think I'm just finding it. Where is it? I started on pages index.js, and then I moved to the layout component, which used footer. Layout I also converted to TS. All right, so we were on pages index, movies list, hooks use favorites. Got it, which used local storage item. All right. Let's convert use favorites to TS. It doesn't have any JSX, so it's a .ts file. Here we have a couple of errors. Name implicitly has any. Can we infer it? String or number. By the way, I think I've touched on this. This little union or vertical bar says it's a union type, a type that can be either or. Here we're saying name can be either a string or a number. this case, though, I'm not so sure whether that's right, so I'm going to ignore that for now. I'm also noticing that this hook, similar to my use local storage item hook, is returning an array that seems to be used as a tuple. It's got this favorites value and then this toggle favorite function. So I'm going to as const that. So let's look at inside this function how it's used. Toggle favorite is the callback that's passed. And what it's doing is setting favorites, which is a piece of state stored in local storage, to an object that takes in ... favorites. And then for the name, it toggles or inverts using that exclamation mark bang, whether favorites name is true. All right, so just right off the bat, I'm going to say that favorites is probably a string, or the name is probably string. But just to be sure, what I'm going to do is another good strategy. I'm going to, in my sources in Google Chrome, I'm going to look up toggle, what's this file name? Use favorites. Use favorites.ts. And I'm going to put a breakpoint in this function. Then I'm going to reload the page and use the page until we get to it. Aha, here we go. Here we see that, yep, name is the ID. So maybe a better parameter name for that would have been ID. So I'm actually going to make that update, and it's a string. So I'm pressing F2 on my keyboard to rename, which you can also do by right-clicking and rename symbol, a little F2 shortcut there, ID, and that's type string. Yay. So that's a great strategy for converting to TypeScript. If you're never sure, or if you're ever unsure what type of value is, if you can hit that thing in the Chrome DevTools or your browser DevTools, I'd recommend doing it. In theory, I could more exhaustively use the app and then also look at other places where it's used, which I'm actually going to do now because we saw earlier TypeScript thought it might be a number. So if I do a full text search on use favorites, I see it's used in the use favorites test file and some other stuff. And actually tests are always a really good way to see what values are passed to places. So I see there are a few tests here. It sets a favorite to true when it doesn't yet exist. So hook.result.current, there it is. Current one is being called with the ID, which is type string up here. Render hook, if you've never used it, is from testing library React hooks. I believe they might have refactored this library's exports or moved it into some other library, I'm not sure. So you might use it under a different name now. I haven't looked too deep into it. But anyway, we're rendering the hook and then calling current, which is this, there we go, hover. There we go, which the second item or index one is our ID function. So it's taking in string in both of these functions. So I think it's safe to assume it's a string. Let me know if you have any questions or comments. It's been a little bit. We also have another squiggly in this. Favorites is this empty object type, which I briefly mentioned earlier and then didn't really dive into. Element implicitly has an any type because expression of type string, blah, blah, blah. What is this saying? No index signature with a parameter type string was found on type empty object. TypeScript is inferring that this blank values variables type is an object with nothing on it. It's an object with no properties, no member functions, methods, whatever. And it's also, because blank value is being passed to use local storage item, inferring that the generic type parameter for use local storage item is that empty object. But we see here that the initial value has an ID string, which is true, and that later on, some arbitrary string ID on that object is going to set it to true or false. So we know that interface favorites, let's say we want to describe our type, interface favorites actually needs to be able to say that for any ID string, the value is Boolean. And that's the syntax with which you can describe that. We say that any, and by any property, we put in these array brackets, any property that we pass in, that we try to use, we are going to say it's type string. So you couldn't use like number or whatnot. And then the value under it is going to be Boolean. And voila, by saying blank value and initial value are this favorites type, we no longer have any red squigglies. Yay, value is type favorites in our set favorites. Cool. So that's how you describe favorites. And that's how, in general, you describe an object that has an arbitrary key or an init signature. See a good question in the chat. Is it the same scenario you explained earlier when deciding to use TS or JS for testing? I recommend use the same language for your tests as your source code. If you're using JavaScript for your source code, and I use source code here to refer just to source part of my cell phone, tests or source code too. It would be weird and difficult to use TypeScript for your tests because you're not able to easily describe the types of things in JavaScript files. There are ways, which I won't go into in this workshop, but it's tricky. And then if you're using TypeScript for your code, it's just kind of annoying to then use JavaScript for your tests. There are a lot of really good development time helpers, such as refactorings and go to definition that are powered by TypeScript that are not as powerful in JavaScript. So I recommend, if you, same thing as before, if you have more than 3 files, and here I will explicitly say, including tests, I recommend TypeScript. So I hope that answers the question. Please let me know if not. Cool. Moving on. Movies list was the last thing to use favorites, and then it also uses another hook, use favorites filter, which uses the select component. All right. Select.tsx. And immediately we need to make a props type. So I'm going to quickly do that. Or interface select props. I'm going to paste those. And fun fact, you don't actually have to say the type of something in an interface. You can just leave it with a semicolon or no at the end. Right now, my TypeScript is configured to complain when something implicitly has an any type. We saw this earlier with parameters for functions, and the interface properties are the same. TypeScript can't figure out what this type is, so it's complaining. Now, you don't have to live like that. That's the strict way of using TypeScript. It's part of the family of settings enabled under strict true. It's called no implicit any. Enable error reporting for expressions and declarations, so things with an implied any type. And if you're having a lot of pain from this, you can always turn that off. You can say no implicit any false, which language server is being slow. I'm gonna restart TS server. Should complain. There we go. It sees that these things exist and don't have a type. Now, I recommend use no implicit any false very sparingly. It removes type safety, or it allows you to remove type safety. It doesn't force you to add types where needed. But if you're converting from JavaScript to TypeScript and you have a lot of code to get through, maybe it's useful. I still generally recommend don't use that flag. Force yourself to convert things. So now we have to figure out what these props are supposed to be. We have on change, options, and selected. Well, going in reverse order, because I see only options and selected are going to be easily, I think, identified or more straightforward. The select value is the selected thing. And I see in the app, we only have 2 selects on the page. And actually, I'm going to show another nice little tip. If you haven't yet installed the React DevTools, oh boy, remove all breakpoints and play. Highly recommend. They're really useful. If you just, on your search engine of choice, look up React DevTools and then your browser name, you'll find them. They'll show you a nice full tree of what's in your component. Here we see movie with the favorite star are the 2 components that get repeated a lot. And then I'm just going to use their nice little select tool. See, these are the only 2 selects on the page. If we search for select, there are only 2 instances found. And these selects only have 1 selected current value at the time, at any time, which makes me feel confident that the selected prop, therefore, is a string. Yay. And if we search for every place that uses select, it's used in favorites filter and sorter. Here we have use sorter, a thing we haven't even looked at yet, which has sorter name string that TypeScript has inferred. So without going into how it did that, that's good to know that it's a string. And then in the other place, selected is this filter name variable, which TypeScript has inferred to be string also. So yay, selected is a string. We also have options, which is an array of something. I see that option is, well, used as the key for the option component of the JSX intrinsic element, as it's called. So I'm just going to say that's a string array. And again, if we look at the components, we see they're just string options. And another thing we can do actually is we can go to the React DevTools and we can inspect what the types are for the props, the actual values. So here we see that props for the first select is onChange is the function, options is a string array, and select is a string. Same with the other one, it's function, string array, string. Yay, React DevTools. If you were converting something that doesn't have really lovely, beautiful React DevTools equivalent, like say a Node app, you could also plop a breakpoint into your debugger of choice and then use a similar strategy. And just to show doing that, I'm going to go to select.tsx, plop a breakpoint in, and whoa, Chrome is being weird, but we see in our DevTools that selected is a string and options is a string array. This is a fun little Chrome bug. Look at this, it's not showing the page. Weird. Okay. So the last thing is onChange. Now, event.target.value is being passed to it, and we see it's a string. Oops. So I'm pretty confident that this is something that takes in a value, string, and returns nothing. Void is, again, the keyword saying this function, you can ignore the result of it. And just to be sure, I'm going to, again, look at the two places this is used. Use sorter.js and use favorites filter. OnChange is set sorter name, which is type takes in string, returns void. And then use favorites filter is similar. OnChange is set filter name, which is type takes in string, returns void. Yay. So I'm feeling confident that this select is good. Now, what would happen if I were to have messed this up? Let's say we take in value number. Well, I guess this would complain. So let's just pretend that this isn't going to give us grief. I'm going to ts expect error just to show off what would happen. Yay. As soon as we try to convert a file that uses select TypeScript, TypeScript would yell at us. If we had, say, gotten this wrong, TypeScript would then, in our use favorites filter, which is a TSX because it renders the select, it would look at this onChange, it would see that it's supposed to take a number, and it would yell at us, hey, you are passing something that takes in a string as a prop to something that takes in a number. Wrong. And if we were to fix it, the ts expect error goes away, and this red squiggly, this compiler complaint goes away. Yay. So this goes to show that it's okay to get things wrong a little bit initially when you're converting to TypeScript. As you continue to run the conversion, you will find corrections to what you had previously done. I also have never seen a TypeScript conversion happen without, oh, wait, we messed up the types a little bit, at least once or twice in the conversion. So as long as you're not changing runtime behavior, that's mostly safe. I would recommend being cautious about types during a TypeScript conversion, as you never know when they're actually slightly wrong. You don't want to use a wrong type to inform your decision about code and then cause a bug. Yay, uncertainty, fear, and doubt. I also want to give another notice on time. We've been here about, I think, an hour and 20 minutes for the workshop. I don't like running more than an hour and a half, so we're not going to get through the entire code base. So I'm going to probably just stop here. Luke, is this, I see you're back on. What I'm going to do is I'm going to send a pull request to the repo that has all the changes, and then I will link you to a past pull request that did convert the entire thing to TypeScript. Cool.
Awesome.
So let's just check out the log rockets aug1 2022. Can you believe it's August already? Ridiculous.
Yeah. Real quick.
Yeah. Git commit M, work in progress, convert to TypeScript. Git push uorg and log rocket. There we go. Gonna make this a draft post. And I'll post it for you, Luke, in the chat. And then also, if you look at the close pull request there, you can see, let's say, this one, previous conversion that did finish. Cool. So we have no open questions in the chat, and I am here ready, willing, and able to answer any questions anyone might have. TypeScript, movies, or other.
I just saw everything everywhere all at once. It was amazing.
So good.
Yeah.
So good.
Yeah, good questions, everyone. Obviously, yeah, if you've got like a huge app, I assume you want to create a pretty comprehensive plan before you start this process. Is there like a approach or maybe even a tool to like get a better understanding of dependencies and try to map that out and be like, this is going to be really gross and here's all the ones we can do quickly, or try to start prioritizing like areas of your app to start the process?
It's an excellent question. I'm going to treat it as two or three questions. One is general ideas around planning, strategizing a conversion. Two is general good ideas around finding which parts of the app to start on first. And then three is tools to do the conversion. For planning, strategizing, and conversion, the most important thing is that it is easiest, it is most successful in my experience when there's at least one person on a team who's really excited and knowledgeable about TypeScript. You can learn it during the conversion, but I'd recommend trying to have at least one leader person get started quickly. If it's just you converting your own project, then great, you be that person. You use the conversion to teach yourself. But if you're on a team with 5 people, 20 people, whatnot, maybe try to pick someone to lead the conversion and then have other folks, maybe one member per product squad or however you divide your developers up, be the enthusiast for that group of people. I'm also going to link you a blog post that describes this in more detail, Academy, Medium, TypeScript. We did a kind of a deep dive blog post on this when I led the conversion at Codecademy that describes a system of having, champions, which is the area expert folks, and additional cheerleaders, which are people who are excited but maybe not knowledgeable about TypeScript. Does that make sense for the first question so far?
Yeah.
Cool. Second is, I recommend look at your app architecture from a high view and pick the leaf nodes there. In a lot of front-end apps, that ends up being the design system. The design system is a great place to start a TypeScript conversion, both because it tends to not have a lot of dependencies, and also because design systems typically are already fairly well documented and very strict. You don't have like weird edge cases the way you do in your core legacy logic. You have buttons and inputs and stuff like that. And hopefully you're using a shared library like React Hook Form or something, so you don't have to do your own complicated form logic. So definitely recommend the design system, and then in general, leaf nodes for your application. Does that sound good and answer the question so far, part 2?
Yeah, for sure.
Cool.
Lastly, that came up from the refactoring thing, just like looking at someone else's code and then being able to quickly split it out when doing this process makes everything easier.
Absolutely, yeah. The last thing I want to plug there is I do actually have a project. It's very experimental, early stage, called TypeStat, which can convert code from JavaScript to TypeScript automatically. It'll do the process that I just showed programmatically. It'll keep iterating on your code base. Very new in that it's only a few years old, very unstable, but we used it at Codecademy and it was very helpful in at least getting us started on conversions. So run TypeStat and see what it has an easier time with, and then maybe get those parts of the code base checked in, converted to TypeScript first. And also file bugs and feature requests as you see them, please.
Nice. Cool. Looks like we had one more in the Q&A.
Yes. Is it better to code in vanilla JS and convert to TS, or is it better to implement TS from the start? I ask because I feel like using TS from start may slow the development process. Oh, I love this. Love this question so much. It's hard to answer in absolutes, But in general, from my experiences and my personal opinions, I would recommend using TypeScript from the start, even though it may slow down your development process. And I'll give you 2 reasons for that. One is that code that's architected in TypeScript tends to play well with TypeScript. When you already have the type checker yelling at you for doing things that are unsafe from the beginning, you tend to play a little safer. In addition to just having the benefits of TypeScript from the start. So that's one thing. You get the benefits and architecture decisions that are flavored by TypeScript, informed by TypeScript from the start. 2 is that slowness is not necessarily a bad thing. If you need to learn TypeScript, or if it would be beneficial for your team to learn TypeScript, doing it earlier is, in general, often a very good thing. So you might have a slower dev process to start while you're learning TypeScript, but you will later on be more experienced with it and be able to benefit from it for your future decisions. So even if you're scared for good reasons that you don't want to slow down, you don't know it yet, I would recommend, if you can, just do it as soon as possible, because it really is useful and will help you with your code a lot, and start finding and improving your code bases, problems and bugs sooner. Let me know if that makes sense.
Silence is gold. All right, that looks like, oh wait, there we go.
You're welcome.
Thank you. There we go. Awesome, Josh. Thank you so much. This was really helpful. A lot of things that I thought were much harder are seemingly a little easier now. So that's great. And yeah, hopefully we'll set up a part 2 to this. But yeah, thanks, Josh. Thanks everyone for hanging around. And yeah, we'll send all the links we went through, as well as the recording and all kinds of fun stuff as a follow-up. Yeah, we'll see you soon. Thanks for joining.
Thanks for coming, everyone. And one last plug, follow me on Twitter. I post cool things about TypeScript, and I've started posting blog posts. Please do buy my book, Learning TypeScript, and give it 5 stars. I hate asking people for this because I feel like an internet shill, but it really is beneficial for me and helps support sustainable TypeScript development. Lastly, on that note, you can also sponsor me on github.com/sponsors/Joshua K. Goldberg. I do a lot of really important open source work in the TypeScript world, and every little bit helps, whether it's one time, $1 a month, $10 a month, whatever. If you work in TypeScript, you probably use some libraries that I've at the very least contributed to, including TypeScript itself. So please support me. Thanks, everyone.
Thanks, Josh. See you.